Okay. So we looked previously at proving that the sum of two even numbers is always even, and now we're going to look at proving that the sum of two odd numbers is also always even. So like 3 plus 3 is 6, 3 plus 7 is 10, 9 plus 11 is 20. So two odd numbers added together always makes an even number. And here we have this expression 2n minus 1, and the 2n minus 1 will always produce an odd number. So for example, 2 times 1 minus 1 is 1, and 2 times 2 minus 1 is 3. 2 times 3 minus 1 is 5, and then 2 times 4 is 8 minus 1 is 7, 2 times 5 is 10 minus 1 is 9, and 2 times 6 is 12 minus 1 is 11. So it always produces an odd number. And also, any odd number can be represented using this expression. I can always find some n to give me whatever odd number I want. So, I mean, for example, if I had, I don't know, 159, I just write 159 equals 2n minus 1. Add 1 to each side, I get 160 equals 2n, and divide by 2, and I get 80 equals n. So if I plug in 80 to this formula, I'll get 159. So I can do that with any odd number. So what I'm going to do is I'm going to take this expression 2n minus 1. That's some odd number, don't know what it is. And over here 2m minus 1. So this is a different odd number because n and m are different. Different inputs, two different odd numbers, and I'm going to add them together. So if I open up the parentheses and combine like terms a little bit here, we have 2n plus 2m minus 2. And then I can do kind of a reverse distributive property thing again here and pull 2 out of each of these, and I have 2n plus m minus 1. And here we have 2 times something. We don't know what this something is, but going back to our previous work, we can see that 2 times anything will always be even, so this sum here will always be even. So if I take two odd numbers, I don't know what they are, right? But whatever they are, if I add them together, I can simplify the expression, and I get this, which is always going to be an even number. And you can test it out. If I plug in some numbers for n and m, 2 times, let's give it 5 plus 7 minus 1. So 5 plus 7 is 12, minus 1 is 11, times 2 is 22. Or if I did 2, we'll make it 6. We'll replace n with 6 and m with 4, minus 1. 6 plus 4 is 10, minus 1 is 9, times 2, 18. So no matter what m and n are, I will always get an even number here. So which means that no matter what n and m are up here, I will always get an even number. And no matter what n and m are up here, based on what we saw over here, these two parts of the expression will always be odd. So no matter what n and m are, odd, that's odd, but odd plus odd will be even.